Welcome back. So we are learning about the circuit analysis techniques. Okay, and now we are going to see about that if we have circuits with the series and parallel combination of resistors, so how we can analyze such kind of circuits. So basically, for basic circuits analysis technique, we rely on KVL and KCL techniques. But once we have a kind of a complex circuits with the multiple series and parallel resistors combinations, so first we try to simplify our circuit, and then we calculate the voltage and currents, and sometimes we do the backtracking to get the actual desired output. So basically the rule is if we have a resistors in series, okay, we just add them together to get the basically the total resistance. Okay, like if I have resistors in series like this one, like this is R1, this is R2, this is R3, so I will just add them together, okay, to get the total resistance. Okay, let's say between point A and B. Okay, so resistance between point A and B will be R1, R2 plus R3. Okay, so if these resistors are in parallel, like for example, parallel means a node, a branch is basically sharing two nodes. Okay, so let's say like this is R1, this is R2, and this is R3. So this is like node A and this is node B. So all these branches are basically sharing two nodes, nodes A and B. So they are in parallel. So for the parallel case, if you want to get the net resistance, for example, RAB, okay, so what we can do, we can just calculate like 1 over R1 plus 1 over R2 plus 1 over R3, and we take basically inverse of this. That will be the equivalent resistance. Or like simply like if we have two resistors in parallel, okay, like R1 times R2, and you want to get the equivalent resistance from this end, let's say this is A and B. So simply we can say the same thing like 1 over R1 plus 1 over R2 inverse, or like if you simplify this one, this could also be equivalent to this one, like uh, multiply these two resistance divided by sum of these resistance. Okay, so the simplification of this thing is same thing. So maybe we can use this shortcut sometimes, or we can calculate using this thing. So let's try to find out the resistance between node A and B. Okay, so we have a circuit and we want to find what is the resistance if we see the circuit from this side. So the rule is like whenever you want to analyze any circuit, like you want to find the equivalent resistance between two terminals, always start from the end of the circuit. So we can, if we look at this circuit, so we want to find from here, so the end of the circuit is this. Okay, so we will start from this end of the circuit. Another thing that you can do, you can put up the labels on the nodes, okay, to help you for the easy understanding. For example, I can say that, let's say this node is C, okay, this node is D, okay, this could be E, this could be F, this could be G, and this could be, okay, this is B actually. Okay, so you can put up like label the nodes for the easiness. Okay, so we will start from the end of the circuit. So if we look from the end of the circuit, we can see that basically these two branches, 1 kilo ohm and 2 kilo ohm, they are basically sharing one node only, right? So it means they are in series. So series means 1 kilo ohm, 2 kilo ohm. So 1 kilo plus 2 kilo ohm. So this will become basically 3 kilo. So we can say that basically between nodes C and E, okay, there is a resistor of 3 kilo. So if I plug that resistor here, for example, okay, this is the equivalent resistance between E and C, which is basically what? 3 kilo. Okay, so we replace these two resistors with this 3 kilo ohm resistor. Now if you look at this resistor, so this resistor 3 kilo ohm is connected between node E and C. Across the same node, we have another resistor which is 6 kilo. So because this 3 kilo and 6 kilo, they are sharing two nodes, so it means they are in parallel. So 3K is basically parallel with 6K. So we can calculate their equivalent. How we can calculate equivalent? 1 over 3 plus 1 over 6 inverse, that basically becomes 2K. Okay. So we can say that like between C and E, we have a resistor of 2 kilo ohm. Okay, let's try to redraw the circuit. Okay, we can redraw our circuit, okay, to better understand, okay, with the steps which we are basically doing. Okay, so I reach F, this is E, this is 2K, this is 6K, this is 6K, this is 9K, and this is 4K. And here we have our 10K. Okay, now between C and E, we have found that there is a basically net equivalent resistance of 2K. So I can put that 2K here. Okay, this is point C and this is point E. Okay, and this is A and B. So now if we look at these points, okay, so now we can see that, so basically this 10 kilo and this 2 kilo, they are connected through this one node. Okay, so it means they are in series. So I can say that basically 10K plus 2K, that will be basically what? Simple 12K. So when 10K and 2K become 12K, so it means I can replace this branch with a resistor of 12K. And where it will come? That will come like I can connect that resistor like at this node which is F and at this node which is E. So what we can do, we can replace basically this resistor with a resistor of how much value? We can replace this with a resistor of how much equivalent value? 12K. Okay, so we have reached till this point. Okay, now if you look at this resistor, so 6K and 12K, okay, they are sharing two nodes like F and E. So once a resistor share two nodes, it means they are in parallel. So 12K and 6K parallel, what will be that? So when 12 and 6K become parallel, okay, so we can do basically 1 over 6 and we have 1 over 12. Okay, so 1 over 6 and 1 over 12. Okay, it's inverse. So what is the equivalent of this one? 4K, right? So it means we can say that this 6K, they become in parallel. So if I just redraw this circuit again here, if you wish, you can redraw the circuit at every steps to make it easier for you to understand. So this is 6K, this is 2K, here we have 9K, this is 4K, this is 2K. And now between F and E, okay, like this is F and this is E, we have basically a resistor of how much value? 4 kilo. Okay, this one. Okay, now next, if you look at what we can find here, we can see that basically this resistor 2K and this 4K, okay, they are in series. Another like indication to find that the branches are in series or parallel, that you can see the current. Okay, so like if the same current is flowing through resistors, that will be in series. So basically, if like let's say an imaginary current I is coming, so that same current will be flowing here. So we can say that basically 2K and 4K are in series. So 2K and 4K, it will become a 6K. So it means I can replace basically these two resistors with one resistors. Okay, and I connect at the same point. Okay, here, and this value has basically 6K. Okay, so this is our point basically F. Okay, this was G. So basically F is gone now because we have simplified that, and this is connected between E. So now if you look at this circuit, we can say that basically this 6 kilo which is connected between G and E, so there is another resistor, okay, of this 6 kilo which is also connected between two nodes G and E, okay, which is also connected between two nodes G and E. So what does this mean? It means 6K and 6K basically is in parallel. So what is 6K parallel with 6K? So again same thing, 1 over 6 plus 1 over 6 inverse, that will become basically 3K. So it means if I redraw this circuit, what we have now here? I have 2K, I have this 4K, okay, and then between G and E, basically we have a resistor of how much value? Of 3K, right? Like this is point G okay, and this was the point E. Okay, 6K become 3K, and we have basically this resistor here 9K. Okay, now what is next? Now we can look at this circuit and we can find out basically this 3K and 9K, they are in series, okay, because same current will flow, or basically they are sharing one node. So 9 and 3, 12. Okay, so what I can do, I can say that basically I can replace these two resistors with one resistor with a value of how much? With a value of 9 and 3, 12K. Okay, so that will be connected between G and B because this node is B, right? So now between G and B, I have 12K and 4K. It means this 12K and this 4K, they are in parallel. So 12K, 4K parallel, it will also be 3 kilo. Okay. So it means I can replace these two resistors also, okay, with one resistor. Okay, that will be connected basically between point G and B with a value of how much? 3K. Okay, now what we have here? Okay, so basically now this 2K and 3K, because they just share one node only, so they are in series. So basically 2K and 3K. So look, if you look from this end, so the resistance between A and B will be basically what? 2 plus 3 is equal to 5 kilo. Okay. So this is how basically we analyze such circuits to find the equivalent resistance. Thank you so much.